Hi, I'm Dr. Tom Calabrese, and welcome to this edition of Insights into Computer Science. This week, we'll be looking at how to get started using a programming language. As you will see, programming is a useful and fun tool that can be used to create many algorithmic solutions to the problems that we've previously discussed. There are many programming languages to choose from, but we are going to start with the Python programming language. The reason for this choice is that Python is a relatively new language that was designed to be easy to learn, robust in terms of features, and very intuitive. Today, Python has earned the status of being the most widely used programming language in the world, as it had surpassed Java last year. Python was originally created in the early 1990s by Guido van Rossum in the Netherlands. Currently, Python is maintained by the Python Software Foundation and is an open source language. This means that users can have access to the source code and propose and make modifications to it as needed. Of course, Van Rossum does still retain the right to make all final modifications to the language. The source code is freely available through python.org. This code is the interpreted version of Python for a variety of platforms and also includes IDLE, the Python IDE or Integrated Development Environment. The IDE allows programmers to create programs, save them, debug them, and run them. As you will see, the IDE makes creating much easier than working with the Python shell directly. Python is an interpreted language, meaning it is translated from source code or program instruction into object code at every execution or one line at a time. Python is also loosely typed as a language. This means it is less likely that programmers will make errors in assigning variable types to data, something that we will see can be very difficult to deal with in other languages. In Python, everything is an object. Objects are instances of real-world things that the language recognizes. All objects have three important characteristics. First, attributes. These are the things that make up what an object is. So, for example, an integer has the attribute that adding 1 to it brings us to the next integer. Another attribute is that there's no fractional part to the number. In the case of a string object, or a collection of characters grouped together, say a word, an attribute is that all strings are immutable, meaning that they exist as is and cannot be changed once established. Second, methods. These are the things you can do to an object or use on an object. Basically, these are functions or programs that are appropriate for use with the object. In the case of a string object, we have methods that change the string to all uppercase or all lowercase. Or we have a method like find that checks to see if an item is in the string. Third is inheritance. Objects are members of classes, and if I create a new object in a class, it inherits all the attributes and methods common to that class. So at this point, you might want to take a moment and go to python.org and look around. There are many things to see. First is the download. Simply choose the type of operating system that you are running and download the appropriate version to match your system and let it install. Make sure that you also install the IDLE IDE as well as the Python shell. The procedure is pretty self-contained and requires little user intervention, as you'll see. While there are many versions available dating back to the 2.x series, I would strongly encourage you to choose the latest version. So take a minute and install Python and the IDE. All set? That's great. Before we begin, take a look at the wealth of support material that is available on the site. They have a beginner's guide for getting started, the download section, which you just looked at, complete documentation, a job site, and if you dig around, you'll find that somewhere there are some awesome program examples to try and look through and experiment with. In addition to the python.org site, you will also find tons of sites that have FAQs and programming tips that will be useful for you to use as you advance. Okay, then let's do this. I think the best way to learn a language is really to just dive in. And remember, there is nothing to worry about. If you make a mistake, Python will not let you hurt your system. So let's have at it. Open up the Python shell and you'll see the triple angle prompt. Type in 2 plus 2. Hit the enter key and Python will return 4. Easy enough, but it's a really important idea because it reveals how the interpreter works. You see, for each instruction entered at the triple angle prompt or presented to the interpreter, Python reads the instruction, in this case 2 plus 2, evaluates it, coming up with the answer 4, and prints the answer to the screen. This is known as the interpreter read, evaluate, and print loop, and it happens every time you enter any command or do anything. Now remember that we said everything in Python is an object. Well, in Python, any number that we introduce at the triple angle prompt is dealt with as an object. So if we type in the number 1, Python knows that it is a number and it can determine if it is an integer, floating point, or complex number. That's a number with a real part and an imaginary part. What's important here is that Python makes that determination without you having to tell it. This is the part that really simplifies programming in Python. Now, while it is helpful to watch Python evaluate expressions, it is more likely that you will want to save those results in a variable. Variables are places in memory that are assigned names so that we can access them easily and recover our information. Variables need to be assigned values. Assignment is made in Python, as it is in most programming languages, through the use of the single equal sign. So let's say that you know that the value of pi is 3.1415. You can assign that to a variable of any name. I think we'll use pi for short. To do this, we type pi equals 3.1415. Python reads this, evaluates it, and stores it away. Python interprets the instruction as assign the value 3.1415 to the variable pi. Later, we can recall this variable as many times as we want. So let's say that you have a circle with a radius of 4. We can save that by saying little r equals 4. Then we can compute and save the circumference by saying CIRC, or circumference, is assigned 2 times pi times r. And we print it out by recalling circ. So we type that in at the triple angle prompt and get 25.132. That seems very useful. By way of illustration, suppose that you have a variable a and you assign it the number 10. That means that somewhere in memory, you have created a slot of memory big enough to hold an integer, and you have put the value 10 there. More precisely, you have stored the binary 00000000000000000000001010. So a 32-bit integer. Now assign the value 5 to b, and likewise we will store that in a binary 32-bit integer with the value 5 at a different location in memory. Now if we say a is assigned b, or a equal b syntactically, that means that we have the value of b, or 5, and assign it to the variable a. So if we recall the a, we will see that it now contains the 5 and not the 10 that we originally put there. It turns out that there are a good number of math operators that are available for you to use. There's the equal or assign sign, addition, subtraction, multiplication, division, or the double slash for integer division. So for example, 9/2 yields 4 and not 4.5. Or mod with the percent sign, which means the remainder of a division. So 9% 2 would return 1, and of course there's the double star for exponentiation. Okay, so now pause the video and try them all out. Actually do it and get a feel for how they work. Don't just watch, do. Try them all? Great. Now, my goal is to have you do something fun and special by the end of this video. We're going to make a spirograph program that draws polygons of various sizes overlapping on the screen from a common starting point. You may remember this from a toy from when you were little. It's one of the coolest doodling toys ever created. I'm giving away my age again. At any rate, before we can do that, we need to learn a little bit about program control. Program control comes in 4 types: sequencing, selection, conditional, and iteration. Iteration is perhaps the most fundamental of the 4 and is at the root of many algorithms, including the one we're going to work on today. Today we will want to draw polygon after polygon of various sizes, and we're going to need iteration to do that. The base statement for this is for, a reserved word that basically means to iterate. I, a variable name that can be used to count the number of iterations. In range, another set of reserved words that let the compiler know that an applied range of values is coming next. Then there's the parentheses start value, stop value, and count by value, the range specification. In this case, we're going to use 0, 5, and 1, or start I at 0, continue until it equals 5, and count by 1 every time we finish one iteration of the loop. This is followed by a colon, which means that the block of code to be executed with each iteration follows in an indented block. In this sample case, that block consists of one line of code, notice that it is indented, that prints the word number, then a space, and the value of I so that you can see the counting process unfold. It is important to note that every line below the 4 that is indented to the same level as the print or more is considered part of the loop. Any code that is at the same level of indenting as the 4 or less will happen after the 4 completes. Okay, try it. What do you see? You should see the number 0, number 1, number 2, number 3, number 4. Notice that it did not print number 5. Why not? Well, that's because the incrementing of I after each print statement, notice that the first one said number 0. So when it reached 5, the loop matched it to the stopping point and then ended the loop before it could print number 5. Now notice also that we did in fact print 5 things: number 0, number 1, number 2, number 3, and number 4. Okay, now we can create our spirograph polygon program. I will be pointing out some features of Python as we input the code. Now, of course, I already flowcharted the design prior to writing the code, but since we're focusing on the Python programming part, we'll just gloss over that part today. The design calls for a couple of interesting things that we will discuss as we review the code. First is the creation of what is known as a function. Functions allow us to create a piece of code, separate it from the main body of the code that we are going to be able to reuse over and over. In this case, the function simply draws the polygon. Now, what makes a function interesting is that we can change the input parameters each time we call it. We do this by passing arguments to the function. In this case, we will pass the name of the turtle that we are working with, the length of its sides, or the length of the polygon sides we will draw, and the number of sides to be represented in that polygon. Second, we are going to use the turtle object to draw the actual polygons. Now, there are many ways to draw and do graphics in Python, but the turtle object is one of the simpler and easier ones to learn. Third, there will be a couple of loops to control our turtle. Okay, so let's get started. To start, I will use the hashtag to create a comment that we're going to import the turtle with the next command. Remember, comments are really key to making our programs easier to debug and more readable for future refinements. The next line calls for us to import the turtle object. What that means is that the turtle object is not native to Python and as such must be brought into the environment by way of the import command. This command searches through the libraries available on your system, and if it finds turtle and all its methods, the program will be made available for you to use. As you can see, if I type the word turtle, I can check to see if the object is resident. Next, I will name the turtle. I chose to name it Henry, and I do this with the statement Henry equals turtle dot turtle with a capital T, parentheses. Please note that the capitalizations of the first T and the second turtle. The reason we do this is that we have many instances of the turtle object in our program, if we want, running at the same time. By giving them each a name, we would be able to control them independently from one another. To use turtle objects, we need to refer to our turtle reference guide, which can be found online. The methods of interest to us today are pen up, pen down, turn left, turn right, move forward, move backward. To quickly go over these methods, pretend that the turtle has a pen attached to its tail. Up lifts the pen off the canvas, so no marks are made when it moves. Down lowers it to contact the canvas. Now, if we move the turtle forward some distance measured in pixels, or backward some distance measured in pixels, with the pen up, you'll see nothing. However, if we had lowered the pen, then we would see a line that follows the path of the turtle. The combination of these ideas can allow you to make some pretty interesting drawings. Of course, we need to turn the turtle, so we use the left or right commands to turn the turtle right or left, respectively, some number of degrees. With all that in mind, the next thing that we want to do is move the turtle to a place on the screen that we want as the root of our spirograph. To do this, we pick up the pen, move 300 pixels backwards, and turn 90 degrees to the left. Since all of this is done with the pen up, no marks appear on the canvas. Next, we will create the function for drawing the polygon we talked about earlier. To do this, we need to use the keyword def. Def defines the header of the function. In this case, we name the function drawPoly. We're going to use 3 dummy variables to receive passed parameters that are myTurtle to hold the name of the turtle, sideLength to hold the length of the sides passed in pixels, and numSides to hold an integer value for the number of sides in the polygon. We terminate this line with the semicolon. This lets the interpreter know that following this line are the commands, all of which are indented just like the for loops we have looked at earlier that are part of the function. In this function, we start by calculating the angle of each turn by taking 360 degrees and dividing it by the number of sides. The result, which is something we can use, again, we'll put in the variable turn angle. Then we create a loop that is based on a for keyword that counts from 0 to the number of sides, and for each pass, moves the turtle forward the length of one side, turns the turtle to the right equal to the number of degrees calculated above in turn angle, and if you did this just once, you would see that it draws one polygon. Notice that the for loop is indented even further than the define, and as such is recognized as a loop within the function. Finally, we create the program control loop at the end of our main program that will actually use the drawPoly function over and over until the parameters of that loop are satisfied. To start, we have to set up those parameters. So to start at, we're going to use 3, stop at 50, and increment by the variable I by 2 after each iteration. Before we execute the program, can you tell me how many polygons will be created? Well, if you calculated 24, you'd be correct. Just follow the counting in the main control loop. 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 31, 33, 35, 37, 39, 41, 43, 45, 47, and 49. 51 would be up next, but that would be greater than 50, and so the loop would stop before the polygon is drawn. Okay, now that that's all in, just hit the Enter key and watch it go. Now, if there are errors, that's okay. Just go back and check your input. It'll work. Make sure that you look at your punctuation, capitalizations, indentation, and other syntax to make sure that they're correct. One way to make error correcting easier is to create a new program in idle. Type it in, save it, hit run, and then if there's a mistake, you don't need to retype the whole thing. Try it and see what happens. Now, a nice practice assignment for you would be to modify the program so that you can enter any parameters you want to govern the operation of the main loop. To do this, you would need to look up the input and integer commands and see if you can integrate them into the program. By doing this, you could ask the user, how many polygons do you want this program to draw? Further customization could allow you to set the start side length, thus changing the size of the set of polygons or the spirograph. Okay, before we go, I thought it might be interesting to take a look at string objects, as they are important to think not only about numbers, but other characters as well. A string object is a collection of symbols that are kept together in the order in which they were created. So, for example, we could set the variable a to be assigned the word hello, which is a set of alpha characters. Notice that they are entered in quotation marks. Single or double doesn't matter as long as they match. If I then set the variable b to hold the string world, I can use them in a concatenation calculation or the joining of strings indicated by the plus sign, and form an expression variable a plus a blank character plus b to form the string hello world. Now that is interesting, as we can use this to do things like cryptographic algorithms, for example. Strings are known as immutable objects, meaning they cannot be changed during the running of the program. There are many string methods that allow us to perform many operations on strings, like find or change to upper or lower, etc., as you can see in the chart. Well, there you have it, and now you're doing some pretty neat things in Python. My advice to you is to explore the Python documentation, try things, be patient, and keep practicing. And it will not be long before you're creating some pretty terrific programs of your own. Until next time.